to the Decode podcast. This is Rev 1.14.
1.14.
I mean, small aside, normally we have a very similar intro, but did you guys ever think we would even do 14 episodes?
No, I think we're about 12 past where I thought we'd crash and burn.
Maybe 12 past what the people want. But we're here at SMTAI International, and we're happy to be here. We're having fun, and we're meeting cool people, seeing cool technology, making friends. I got to go to the Omron lab. They have a really sweet demo facility just like 20 minutes from here. And have you guys ever been to a lab facility like that where you get to see firsthand all the different technology, like up close?
No. Is it kind of like a showroom floor, but working?
Yeah, basically, yeah. And they can dive deep into actual application stuff. Like, he literally showed us how to do an entire program from scratch, offline, send it over to the machine, what that would look like, how you would, like, it was crazy. Like, the SPI specifically, like, I'm fully shopping for an SPI, like, I'm looking at every single option out there, comparing strengths and weaknesses of different platforms and what they all offer. And like, everything I saw today was super impressive for sure. It's the equipment you have, right, in your facility. You've got their SPI and AOI. Is that right? Yeah, we saw both of those things today. That's pretty cool. Do you have yours working in a closed feedback loop like it? No. Is that something you're capable of setting up? Like, is the equipment you have capable of doing it, or does it work with Europlacer stuff?
The speed print.
The speed print. It'll actually correct the parameters within if you have it sending back the info. Yeah. So that's something that's cool. I think, like, no matter who you have, if you can figure out a system that, like,
everything's harmonious.
Yeah, no matter who your screen printer is, but no matter who your SPI is, no matter who your pick and place is, if you can get a system that works cohesively and tells you the complete story. And I mean, because honestly, when it comes to like troubleshooting FMEA, or diagnosing where a problem went wrong in your like if you have a rework and you're trying to figure out like what happened, like how did this occur?
Where did this occur?
Yeah, where did it occur, and how do I prevent it from ever happening again, right? Equipment like that technology, that's how. Like, you can do it without it, but it's going to be a lot more legwork. It's going to take longer, and you're going to have less confidence. When you use the data that's being collected from those machines and you tie it all together, and especially if you have like good traceability where you're barcoding or serializing all of your boards, now you can look back on whatever problem you did have, and you can say, like, well, on that specific board, here's the images from the SPI. This is the volume of paste that was on that component. We saw this percentage of tombstones, say. Did we see the same deviation in our solder printing process, along the way? Or, is it reflow related? Was it, if you're looking at your pick and place, if your AOI images from your pick and place, if you had one pre-reflow and post-reflow, I mean, what a luxury that would be to have, right? To have
confidence,
the whole story, exactly when it happened. What did it look like pasted? What did it look like placed? What did it look like reflowed, right? And if you've got all of that information,
it's a big piece of the battle, right?
You'll know pretty quick if you know how to analyze it.
Yeah, you still need to be able to take that data and find out what it is that you need to do to prevent that, right? But having that traceability to, okay, here's where in the process steps it went wrong. Here's what I'm going to do to address it on a future stencil or placement profile or whatever it is, right?
And for I just thought everything they showed was pretty incredible. Like, they broke down how you program each different package, and then how, like, over time it's going to get easier and easier because it's,
it's
like
intuitive.
Yeah, like that. Once you've taught it, it knows, and it'll recognize that when it pops up again. And like your leg work, the more you have it, the easier it gets. I mean, that's typical with any like library-based machinery. The more you build out your library, the less new, instances you're asking it to understand. So it just gets quicker and quicker to program over time. I thought that was just a lot of the stuff I saw. Like, for example, with the SPI, right? Just a graph of the last 10 boards, what it's doing.
Yeah.
If you see a sawtooth wave of up and down, you instantly know that that's directional. It's working on the front, but not to the rear, or vice versa, or whatever. But like, without that data, without that graph, how do you know that? Are you actually physically looking at every single board? Your eyes won't tell you whether they're not well enough to be like, oh, I'm always seeing this pattern, this direction, and this pattern, this direction.
Were you able to see the 3s flip around of a pasted board?
Yeah, like how you can just twist it and play with it and look at it from every
actual dimensions of where the cube is supposed to be.
Yep, the profile of the expected brick essentially, and then where it's meeting within it.
How much it's off.
Yeah, and I thought certain things that the engineer, like the applications engineer, I don't know his exact title, but like he had a lot of cool information. Like he was teaching how to use overprint detection, how to, like, some things where people ignorantly or not will decide that's not I'm just going to allow all this at a, like, I'm worried about insufficient, or I'm not worried about this top number, and they'll just basically allow anything above it instead of truly setting their.
So they're setting themselves up for excessive solder, wet bridging, all the above.
Yeah, and then he says they frequently ask, well, why is this happening? It's like, well, you're allowing it to happen, And so no matter what brand you have, if you understand, like, how to set up your parameters, how to define what's acceptable and what's not, and where that gray area is, and like the more you can shrink that gray area, and just, that sounds to me like if you've got the right equipment set up the right way, you can get to the point where, like, basically you get a defect, you learn in the process where that was, you eliminate it, that doesn't happen anymore.
Right.
Your detection won't allow that to happen anymore. You change your parameters to prevent that issue from ever happening, so it just never happens again. You've solved that one, and like, if you just keep going through your processes that way, like anything that's even approaching, oh, we're going to start, this is getting close to the limit here, what do we need to change? You can get everything back in, and then you can tighten those, those settings and tolerances,
and walk them towards each other until it's a real tight process.
And you get to the point where everything's optimal.
Tough to sell this to an owner, though, because it provides no
maybe on the front end,
right? Like, in their mind, right? This is going to slow down production.
Well, like the ORAC said, it's not a value add. In their opinion, it doesn't generate revenue. It slows things down. Like you're saying, it's not adding components that get charged.
My sales guy, Tim Anderson, right? He told me I expect to see a return on investment in, I forget the amount of time, right? And at the time I couldn't understand, what do you talk, like, I was exactly like, this is going to slow down production.
Because of less rework though, right? Like
less rework, and the returns, right? There's its back end savings.
Unbelievable amount of less rework, right? And then efficiency too, because there might be something that may have held up whatever it is, right?
Sure.
And then now
that bottleneck is cleared now.
Yep. Like, okay, I'm getting this part. Oh, wow, look, it's also spinning on the pick and place, right? Maybe we should see if is this digitized correctly? Is the Z height correct? Is this right? Right? Is the package correct? Is the height right? Is it placing too hard on just these little things that now take my rework down to nothing, right? And then just,
so while it's not generating revenue, it's preserving revenue.
Correct.
That's the way to look at it.
And then I had a customer that has this Bluetooth chip on there that he purchases because it's specifically programmed for his software, right? It's proprietary, right? And it has all these bottom terminated components on there, and they're pretty close to each other, right? So when I was
The
getting
big
it,
LGA, like big rectangular pads
Yeah.
that are all super close. And
No,
It's
these are
got
tiny.
perimeter pads.
These
and
were
then
little
the
guys.
cluster in the
oh, okay,
Yeah.
little
Yeah.
guys.
Yeah.
Okay.
In fact, it kind of upped my confidence on VGAs with how we saying like how close they were. But anyways, I was getting failures. I don't know, maybe out of every couple hundred, like maybe one or two would come back, and we didn't understand why. I had no clue why, right? And then I got the SPI bridge detected, right? And then now knowing further from our conversations, silkscreen all around that bad
Oh, yeah.
boy, all around it,
Yeah.
right?
And that's right. We've talked about this before, right? Because you had an outer row, a perimeter of pads that were right next to the silk screen, and then an inner row of pads. And the bridging was never on the inner row, right?
Right.
It was always on the
Always,
outer row,
yeah.
but not in the same spot. It would be a random, so it wasn't one isolated. It was randomly throughout the outer perimeter because of the variance in the silk.
Yeah.
Like,
And you're printing plus the thickness of that silk screen, right?
Yeah.
It has to come into the calculus.
Yeah.
yeah, because it's lifting the stencil up.
Yeah.
That height of the, and when you see zoomed in images,
Yeah.
then you
It
can
looks
really,
chunky.
you're like, that
Yeah.
silk's kind of tall.
Yeah.
Like that, it looks two dimensional
Yeah.
from a normal vantage point, right?
forget
You get a
about-
closer view, it's like, no, there's a noticeable elevation to that.
Forget about establishing a good gasket.
Yeah.
I mean, you're off contact.
And this is a Hazel board. Right?
Yeah.
Oh man, now you're talking double whammy.
What we did too is we increased the amount of dry cleaning that it does. So
And you know why?
The stencil wiping,
Yeah.
yeah.
Why? Because without that proper gasket, every time you print, now
You
you've
get
got a bunch
lean.
of solder spheres underneath, and now they're starting to contribute to the issue and
Yeah.
build up.
yeah, because if it's gathering underneath the
Yes.
stencil, now the next board that comes up under there, now you've already got paste smeared contacting the board before you even bring the squeegees over.
And then that's all going to equal.
And so now you're
bridging.
sure. And that is one instance. That's one assembly,
Yeah.
one problem,
Yeah.
one, but it fixes that kind of stuff across all, you know what I'm saying? Like,
It tells you where you need to fix something.
Yeah.
no,
right?
sure. Yeah. If you know what you're looking at. Yeah.
That's part of the reason why I don't have the continuous feedback yet, is because I want to know why. Right? Like I want to know why.
You don't want it to fix itself. You need to
Yeah.
understand what
I-
went wrong and what it does to correct it.
Yeah.
And once you know enough, you'll let
Home
it.
plate, I'm good. I gotta know why, right? I gotta know why it's needed. Why does it help out this? But did you be able to? Did they show
Are you actually? So, are you saying there's a world in which you're going to move away from rectangles and squares?
So we got the new guy that's got 30 years experience.
And he
And he's
says,
telling him stuff that we've been telling him.
And he
but
says-
listens to him.
"Oh, yeah, sure, naturally."
I'm dabbling.
Yeah.
Okay, we're gonna dabble. But were you able to see any of the IPC violations it picks up on the AOI?
No, I'm not sure if
Like just the basic things like end overlap or
we went way more through the SPI
Okay.
than the AOI.
the
for
AOI
sure.
is nuts. So the AOI like has this list of nonconformities in its database somehow, and it can scan that image with those 5 cameras and tell you an overlap, toe overhang, right? Like lifted lead, exposed.
So it has an internal knowledge base of kind of golden examples that it's checking towards without any kind of pre-programming. It's just
It
there
is-
already.
it
You don't have
is
to do anything.
A610 J standard inspector. It is insane. It is crazy.
That is
And obviously, you need someone trained to understand between false call and real call, right? And also take, a couple boards under the scope manually and verify it first until you can get your process like truly. Okay,
Verify.
I'm confident in this, especially if you're not functional testing, right? I need to visually. But the amount of violations that thing shows up, it is amazing to me. It's like the board that I do the most is 710 components, and it scans it in less than 30 seconds.
710 placements.
Placements, yeah, and 71 total per board, 31 I think each unique, right? So, but it's a 10 up, right? So, but it's crazy to me that this thing can scan 710 placements within 30 seconds and then go have such detail. And then they give you a
They're so cool, man. I love these
3D
machines.
image where you can rotate just like you could with the SPI of
Yeah.
like, and then zoom in, zoom out, go from there.
Right. Set it to a heat map to see, what's good and what isn't.
It's crazy. Yeah. It's crazy.
So with that inspection function, as your operator kind of clears as a false negative or says that something actually is erroneous, does it remember those instances for future occurrences? Like, okay, last time I saw something like this, it was a false read, so I'm going to ignore it this time.
We do it on the programming station.
The newer machines are doing that, yes.
Okay.
Like the newest machines are reaching that point where they will, like, okay, that's a new, like, that'll fall into like a new category. This is the first time this instance has happened. All right, so that's like, this was your judgment on that one. Another time that happens again, what was your judgment on that one? And it has to build up a big enough sample size to reach a certain number of confidence, and then it does it for you. Then you no longer have to make that decision. And it even the things that are the judgment calls, that are the fine judgment calls, it even uses your judgment to make it for you. I mean, it's
we do it on
incredible.
The programming station currently. So, for example, like a tantalum cap that has a different date codes on it.
Yeah.
Sometimes maybe one day it was a darker text and the other day it was a lighter text, right?
Mm-hmm.
Or maybe one of the date codes is different from the other date code. It'll pick that up and say this is the wrong component. So then we go back to the programming station, program that new image in, right? And say like these two are okay, right? And then from there on, you're good to go.
So you can have multiple options for the same.
So
component.
it's image comparison.
Yeah. And for that one is specific for wrong component flag.
Okay.
Right. So, and that's why another reason why I hate using the Vishays, right?
Does that also, just like a lot of times I know, like just the direction the silk is written shows you whether the part's oriented correctly.
You can program two ways. So, like on a resistor, if it goes like 103 and then 301,
yeah,
depending on how you're reading it, right?
Yeah, because in that situation, polarity won't matter.
Correct.
103 or 301, whatever it's seen is fine.
Yeah.
But on a diode,
it would be an upside down.
Right, that's what I'm saying.
Yeah.
It would.
Because I know there's going to be a guy out there that lives in the Netherlands that's going to say a 103 and a 301 is not the same, right? We're not saying that at all, right?
Sure.
Right?
Sure.
You know what I'm saying?
Sure.
One of them is going to be upside down,
yes.
Right?
Yes. It's an image. Yeah.
Very clear. We understand. Is
the same part.
Yes.
Yeah.
He was getting ready to hit that button too.
He was sitting there. Yeah. So
you said something wrong. It'll be found out.
Oh, I'm sure of it. 100%. Yeah.
Which I love. Again, though, like that's the beauty of having these discussions in public is we don't just get to congratulate each other on our brilliance and knowledge. Other people get to, contribute and say, actually, this is where you're missing something. Or this
give me the Michael Jordan of entire PCBA. It doesn't exist.
Yeah.
It doesn't exist. There's not one.
I know somebody who's going to be offended you said that.
There's close, right?
Just one?
Probably.
There's close, but I mean, if you broach a different subject of stencil manufacturing, right? Or stencil cutouts, or PCB manufacturing, or PCB.
There's so many different facets.
Right?
No one's got a true expertise
Component
in every
manufacturing.
single discipline.
Yeah,
sure.
right? Like placement, maybe, right? Like they're all different and it's all combined under one, but
I mean, honestly, you think about it, anyone who spends their whole career in some, that they don't stop learning, right? So if you're always seeing new stuff, always learning in one discipline, how could you ever expect to know everything, right? Because it's just too much all the time.
Yeah, even like the solder paste guy, right? Like that's one thing, but now you have vapor phase, right? You have nitrogen reflow, you have regular reflow, right? Like you have all these different type of finishes that are going to use your final product.
Well, yeah, sure. I mean, that makes a big difference what kind of finish is on the back.
Exactly,
for sure.
right? Like, and what your profile temp's going to
Yeah.
be. They're all going to vary. So even though you might be an expert in one field and maybe your flux worked it this way.
Well, thank you for joining us on this Rev 1.14. This is our final episode covering our time together at SMTAI International. I know it went too fast for me. I don't know about you guys, but this was a very fun time together, and hopefully listening audience enjoyed it as much as we did.
Or at least half as much.
Sure, that's more reasonable of an expectation. Give them a chance.
Yeah.
So thank you, listening audience, and hopefully we see you again for Rev 1.15. Until next time.